Welcome to Study Loop.
Problem 730. While a roofer is working on a roof that slants at 36 degrees above the horizontal, he accidentally nudges his 85 Newton toolbox, causing it to start sliding downward from rest. If it starts 4.25 meters from the lower edge of the roof, how fast will the toolbox be moving just to reach the other roof? If the kinetic friction acting on it is 22 newtons. Okay, so for this problem, we're going to use work. First off, we need to figure out how much force due to gravity is actually pushing the the toolbox down the roof slant. So to do that, I'm going to make a triangle. And due to triangle similarity, these are two triangles that are similar to each other, and so therefore this has an angle that is 36 as well. 36 degrees as well. And so now, using our trigonometry formulas, we have a right triangle with a hypotenuse of 85 newtons and an angle here. Now, since we're trying to find this length, what we can do is we can use the sine of this angle multiplied by 85 newtons. So we're going to have force due to gravity that is parallel to the slope is going to be equal to 85 newtons times the sine of that angle, so 36, and that's going to be equal to 49.96 newtons. Okay, so this right here, just leave it there, so G parallel. Okay, so now what we can do is we can say we need to find out how much energy this toolbox actually gains as it travels down the slope. And to do that, we can sum up the work done by both gravity and the friction as it travels down this length. So the work due to gravity is going to be this force times that distance. And since the displacement vector is in the same direction as that gravitational force vector, that's going to be a positive amount of work. So we're going to have 49.96 newtons times 4.25 meters. Okay, so that's going to be some positive value. Now we have the work due to friction, so we have mu k. Okay, so that's going to be 22 newtons. It's going to be against the direction of motion, so that's going to be negative 22 newtons times 4.25 meters. Okay, and then so that means that the sum of this work that acts on the block as it travels from the top of this ramp down to the bottom, from the edge of the roof, from the top of the roof down to the bottom. It's just going to be some of those, and immediately sum those up for you. It's going to be 1.118.8 joules. Okay, and so now we know how much energy the toolbox gains as it approaches the edge of the roof. We're asked to find how fast it'll be moving. So what we can do is we can just set up our conservation energy formula. This is going to be the only energy it's gained as it travels down the slope. So that's going to be 118.8 joules is going to be equal to, when we set this equal to UG0, that's going to be, there's only going to be kinetic energy there. So we have 1/2 mass times velocity squared. One thing we don't know is the mass, but we can get that from the gravitational force here. So we know it's 85 newtons, and since that is just equal to mg, what we can do is we can take that 85 and divide it by g. So we can just plug in what we have. So we have 118.8 joules equals 1/2 85. That's gnarly 85 newtons over 9.81 meters per second squared, velocity squared. Okay, so then this is just math and some understanding of our units, but then we should just get velocity in the end. So we have velocity equal to 5.24 meters per second.